ESTCube-1 was placed inside the support called PPOD, then on the same platform with the VNREDSat-1. This platform was then placed inside the Vespa carrying structure. Vespa allows Vega to carry several passengers at once. It's being used tonight for the very first time. On April 15th, Proba-V was placed in the Vespa, which was then covered by the twin halves of the fairing on April 17th. The composite was transferred to the launch zone and placed atop the launcher. The Launch Readiness Review gave the green light to begin the final countdown on the day before launch. On launch day, 2.5 hours before liftoff, the gantry that protects the launcher was moved back 80 meters, and Vega was now ready for her mission. That mission due to start in just 4.5 minutes away. We want to say hello to all our friends taking the broadcast tonight.
Yes, hello to our colleagues at ESA HQ and Dominil, to our other ESA center across Europe, ESTEC, ESOC, ESAC, and especially Redu and Esrin, to which I will say buongiorno frascati.
It's early morning in Estonia and Colleferro as well. Also hello to our friends in Hanoi, where it's coming up to 9 a.m. That's the DDO's voice. She's going to call out the 4-minute mark.
The 4-minute mark is beginning of a complex series of operation running.
Top, H0 moins 4 minutes.
This is the DDO, Amy Sip, who was the range operations manager, calls out milestones before and after liftoff. Why is the 4-minute mark so important?
It is important because it allows the liftoff and letting the launcher becomes autonomous.
It's the final part of the final countdown, I guess.
Yes.
Our cameras are here in the Jupiter Mission Control Building, but the CSG is a big base. A lot of people working at a lot of other places. One of them is up here at the Launch Management Center.
Yes, at this moment, engineers and technicians are following the final checks and verification on all the systems of the Vega launcher, which is done during the final sequence. Next important step for the autonomy of the launch vehicle is the commutation of the OBC, the onboard computer, which will drive the very last operations until ignition.
The Vega Launch Control Center is in the same building as the Ariane 5 Control Center. Mission control, where we are, is provided from the same Jupiter building. It's used for Ariane and Soyuz launches. We're about 14 kilometers away from the pad here in Jupiter. These men and women you're looking at are only about 3 kilometers from the pad.
Yes, but they are protected against any debris inside a sort of blockhouse.
Now, does this mean that there are 2 different control centers and all? Green status panels, continuing to tell the story, all is green.
Yeah.
Do we have 2 different control centers?
Yes, and we used to make similarities between the Vega control center and an airplane cockpit, and between the Jupiter control center and an airport traffic tower control. In Jupiter control center, the launch range manager, the DDO, gives the authorization to lift off once weather forecasts, radar systems, and other systems are okay. In Vega Control Center, people follow the fueling and check the good configuration of the vehicle for the flight. And then the launcher manager, the COL, decides to go.
Jupiter Mission Control here is the nerve center of the space base, the brain, if you will, of launch operations. The workstations, you see, they're staffed by 3 teams in charge of the launcher, the satellites, and the base facilities. The room's divided into 2 parts. You can see the operational people on one side of the fishbowl, in the glass wall, and the VIPs and the guests on this side. The viewing room seats 250. Gives you a good idea of what's going on now, closer to the pad, a final countdown, as you can see, complex and ongoing series of maneuvers to ready everything, the launcher and the base and the downrange tracking stations for the mission. You can't just call out 3, 2, 1 liftoff and push a button. I think in the old days they used to be able to do that, but there are a lot of issues involved today, including safety. You're going to hear the DDO, Amy Sip, our first female DDO, by the way. She's going to call out the 1-minute mark in just a moment, and we'll be into the final 60 seconds.
À tous les DDO, attention pour moins 1 minute. Top, H0 moins 1 minute.
Final 60 seconds. Enrico, we're going to say goodbye momentarily to you.
Yes.
Enrico's going to go outside to watch the launch from the balcony. We'll see you in about 2 or 3 minutes. Huh?
Yes, it's a special moment for me.
All right. Tell us all about it when you come back.
Yeah.
It'll be exciting. There are 2 terraces where the guests and VIPs can watch the liftoff here. As we mentioned, the action takes place about 14 kilometers from here. You get a great view, as Ariane as Vega, I should say, passes. When he comes back, we'll get Enrico's reaction to seeing the liftoff live. You're watching the second Vega flight from Europe's spaceport, Proba-V, VNREDSat-1 and ESTCube-1.
À tous de DDO. Attention pour le décompte final.
Final countdown.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Top. Allumage, décollage. La trajectoire est normale. Tous les paramètres à bord sont normaux.
Well, Vega lifting off perfectly from French Guiana, and right up she went rapidly in the light rain.
Acquisition de la télémesure
Don't know
lanceur
what
par
kind
la
of
station de
visibility
Saint-Jean-du-Maroni en Guyane
Enrico had
française.
out there. It looked like we lost Vega to the clouds pretty quickly. But she's
Tous
beginning
les
her second
paramètres à bord sont normaux.
mission a little over a year after her successful first flight. The DDO is calling out
La
all
trajectoire est normale.
is fine, all is normal on board. 137 tons at liftoff. Ariane 5, you might recall, weighs over 6 times that much. Those of
Tous
you
les
who
paramètres à
are
bord sont
familiar
normaux.
with the Ariane flights know the heavier launcher rises much more slowly than Vega. You saw Vega rise like an arrow, surprisingly quickly if you're used to watching Ariane lift off. Anyway, we were supposed to go, by the way, last Friday. We were technically ready, but we're held up by high altitude winds. But as you can see, we lifted off successfully
La trajectoire est normale.
tonight. All is normal on board. Basically, what's ahead,
Le pilotage est calme.
Vega's first 3 stages rise very rapidly in about 6 minutes. We're into the first stage burn. The first stage will burn another 20 seconds, flame out at about 1:55. The second stage will then ignite and separate at plus 3 minutes and 39 seconds. The third stage will ignite at 3 minutes and 55 seconds and separate at plus 6 minutes 18 seconds, and the AVM, the upper stage, will take over then.
Séparation du premier étage.
We've just had separation of the first stage. You heard the DDO call out. We have first stage weighing 97 tons, 88 tons of that fuel, all
Allumage
of
du
that
deuxième étage.
used up. We're into the second stage burn. And before we talk about the second stage burn, welcome back, Enrico. How was it out there?
Even if there were a lot of clouds, raining clouds.
You didn't see much, did you?
No, not
Tous
very
les
much.
paramètres à
But it
bord
was
sont normaux.
magnifico, you know, because at the beginning
trajectoire
you
est
see a
normale.
little spotlight on the launch pad. There is no sound, and it disappeared. The light disappeared, but then after there is a loud noise that arrives, the music of the propulsion that rolls you from the sky, and it makes you little vibration on your skin, you know, but not
Goosebumps,
little
huh?
vibration, because it's a noise so high that it could seem an earthquake, you know.
La
It's
trajectoire
so
That loud?
Yes,
That loud.
that loud. It's
So you're impressed.
yeah.
Now, you've seen, this is not the first time you've seen a launch.
It's the first Vega anyway.
Tous les
It's
paramètres à bord sont normaux.
I've seen 4 Ariane 5 before, which they are noisier, but for the little Vega, it's quite impressive.
Super. So even with the loss of visibility early on, you still had a lot of noise. You still had an
Yes.
impressive side.
Yes, and this noise, it's a mark of the power of the propulsion, you know. It's and even if you don't see it, you can feel it.
Good. Okay. Well, if that doesn't make you want to come down and watch a launch, folks, I don't know what will. Enrico, back to work. Sorry to put you to work. On the upper left-hand side of the screen, you have the cursor crawling up a line, and below that,
Séparation du
you
deuxième
have 2
étage.
lines, A and V. Can you explain to us what those are?
Yes, yes. The curve is a theoretical path that the launcher has to follow to accomplish its optimized mission. And the little A means altitude of the
troisième
launcher.
étage.
Below, you can see a V, and it's the abbreviation of velocity and speed.
Largage
But
de la
on the
coiffe.
curve, that you can see a little dot that is moving, and that dot is the current real-time position of Vega, given by the data coming from
Tous
the
les
launchers.
paramètres à bord sont
All right,
normaux.
altitude 210 kilometers, speed 4 kilometers per second. Our top speed will be about 7.5 kilometers, so watch for that. While you were giving us that rundown, we had the separation of the fairing. You saw that, revealing to the elements Proba-V, which will be separated a little later on.
Yes, the fairing is jettison because outside the Earth's atmosphere, the fairing it doesn't need it anymore, and so we lightened the launcher of about 550 kilograms.
We're in the third stage burn. The Z9, as they call it, the Z9, the 4-meter-long Z9, though Vega's smallest solid propellant motor, has the longest burn time. She'll burn about 2 minutes, weighs 12 tons again. 10 of those 12 tons are fuel. So a lot of the weight of the vehicle, like for Ariane, is propellant.
Yep.
Coming up on separation of the third stage, we have another minute to burn. Going back to the fairing, industrial team is a big one. Italian, Spanish, German, Belgian, French, Swiss, Ukrainian, and Swedish firms all participate in design and development of the fairing.
Yeah, and the fairing on ground maintains a clean room environment for the precise instrument of the payload, and Proba-V has a very sensitive optical instrument.
And we can release it now, as you said, because we're out of the Earth's atmosphere, and it's designed to protect the satellite from movements and thermal...
They protect against the impact of the dense atmosphere.
And of course, we're out of the atmosphere now, so we don't need it. We're coming up on extinction of the third stage, and then we'll have ignition, first ignition of the oven. There's extinction. You can see it shutting off. The nozzle, you hear the DDO call out the confirmation. You see our speed, and there's a separation of the third stage. Sometimes there's a second or two delay between the time the thing happens, the event happens up there, and the telemetry comes back here into Jupiter, which is why we get the animation a little bit first. But you see, we're doing well. The fourth stage has started its first burn. Fourth stage is called the AVUM, A-V-U-M.
Yes, for attitude and vernier upper mobile. Vernier referring to the thruster that are used for fine adjustment to the attitude or velocity of a spacecraft.
This is different from the lower stages, which use solid propellant.
Yes, exactly. This fourth stage is a liquid propellant engine, and it can be shut down and restart.
Basically, is it fair to say that solid propulsion, like on the first three stages, is used for raw power to get us going? And is it fair to say that the liquid propulsion is a little more sophisticated, used for precision?
Exactly, yes. Because the AVUM is designed to deliver payloads into different orbits and to perform very fine satellites pointing before separating them.
We've been picked up by a downrange tracking station in Bermuda. Vega will pass over it twice. On its first pass, it'll see extinction of the first AVUM burn. Vega's trajectory has been designed to be followed from the ground at all times. The radar is the launcher, I should say, is sending back radar and telemetry to these downrange stations. Now, what's telemetry?
Yes, telemetry is the way we have to stay in touch with the launcher. The downrange telemetry stations receive electromagnetic waves that brings information, thousands of parameters and indicators of Vega health in flight, motor pressure, stage separation event, nozzle activation, and so on. We analyze some of this data in real time, so we know where the satellites have been released, for example. The other data are examined after the flight to find how the vehicle performed. We have downrange telemetry stations in most of the places of the flight by the launcher, Bermuda, Perth, Saskatoon, Lucknow, added to those in French Guiana.
Our altitude, 274 kilometers. Our speed, 7.74 kilometers per second. We're going to go shortly to a replay of the liftoff, a medley, I think, of launch replay shots from different places. You'll be able to see for yourself, once again, those good, very interesting pictures that took place about 8 minutes ago. We're following the second Vega mission. Here's the replay. What that made you recall the moments that you spent out on the balcony there? What went through your mind as you saw those shots?
It recalls my previous job in CNES. I participated to the design of the ground segment of Vega with the people of Esrin and Industrial as Vitrocizet. It was quite hard to answer to all